Hello everyone, good morning. How are you? So today our topic is what? Haloalkanes and haloarenes. Here we are going to talk about the properties of haloalkanes, haloarenes, as well as we are going to, good morning Gauri Lakshmi, good morning. So today we are going to talk about the properties, chemical properties, preparation of haloalkanes as well as haloarenes, right? So am I audible and my screen is visible to you? Okay, so now let's start with our today's session. Okay, haloarenes and haloalkenes. Haloalkanes and haloarenes. Okay, yeah. So in haloalkanes and haloarenes, the difference between is that for haloalkanes, there will be the alkane chain, okay, attached to a given halide group. And for haloarenes, there will be what? Arene group attached to a given halides. Here you can see in this photo, here is what? A carbon chain attached to a halogen. And that's why this is what? Haloalkanes. And here benzene ring, you can see, okay, aromatic ring is attached to a given halide atom. Okay, it can be chlorine, fluorine, bromine, iodine, anything. And you can see the bond length between the carbon and X is shorter and stronger. On the other hand, it is what? Less strong due to what? Single bond of carbon and halide, right? So now let's talk about the preparation first, okay? How you can prepare the given halide, okay, haloalkanes from alcohols. So when you need to prepare halides from alcohol, what we do is we do a simple reaction, that is react our alcohol with the respective hydrogen halide. Okay, you will get the haloalkanes, that is alkyl halide. Okay, haloalkanes are also known as alkyl halides, right? Another reaction which with the help of which we can prepare our halide, okay, alkyl halide, is that react it with the PCl5, phosphorus pentachloride. So here what is going to happen is there will be formation of RCl and POCl and HCl. Okay. Next, react it with the help of what? SOCl2. So these reactions we are going to study in chemical properties of alcohols. Okay, chemical properties of alcohol, in which you are again going to study these reactions. Okay, so here is what? Preparation of what? Haloalkanes from what? Alcohols. Okay, so there are three reactions. If we need to prepare our alkyl halides, that is haloalkanes, that from hydrocarbon, that is another method. So by reacting the given hydrocarbons with hydrogen halide, we get the respective alkyl halides. Okay, so here order of the reactivity for this reaction is what? HI will be more reactive as compared to HCl as compared to HF for adding, for undergoing into addition to a given alkene molecule. Okay, if suppose we consider the unsymmetrical alkene, these reactions we have already studied in hydrocarbon chapter. Okay, if suppose we are talking about here unsymmetrical alkene, here there was a symmetrical alkene, that is 2 carbon atoms were present. If there are unsymmetrical alkenes, like 3 carbon atoms are present, and at 1 carbon there is what? Double bond present. In between 2 carbon there is a double bond present. For example, CH3, CH double bond CH2. So this is our unsymmetrical alkene. So addition of a given hydrogen halide takes place to this carbon-carbon double bond according to M rule. Okay, according to Markovnikov's rule. Only in case of HBr, what happens? That is in presence of peroxide, addition occurs according to this anti-Markovnikov's rule. Okay, addition occurs according to the anti-Markovnikov's rule. Okay, so here you can see I have shown another reaction of alkene with Br2. Okay, here what is happening? 2Br has been added. This is another method of preparation of dihalides. Okay, dihalides. Here you can see another reaction. Methane reacts with Cl2 to form methyl chloride, right? This is again one product. So this is what? Propagation reaction. Okay, this is chain reaction, and that's why here what is happening? The methane molecule reacts with what? Methane molecule reacts with Cl2 to form these type of compounds, right? So this is about the preparation of molecules. Okay, preparation of haloalkanes. Our chapter name is what? Haloalkanes. So right now we are just talking about the preparation of haloalkanes. Here you can see another method with the help of which we can prepare the haloalkanes, that is by using halogen exchange. And this reaction occur, and which is known as Frank-Stein reaction. Here what happens is that our given alkyl halide, that is haloalkane, reacts with the sodium iodide in the presence of acetone, and there is a formation of iodoalkanes and sodium halide as it is. If suppose this reaction of halogen exchange takes place with AgF, then the reaction name changes to Schwarz reaction, and this is a very, very important reaction. Okay, this reaction is most of the time asked in the exam. Okay, whenever there is alkyl halide given and it reacts with the silver fluoride, what is going to form there? There will be preparation of fluoroethane, and this reaction is known as Schwarz reaction. And when the reaction takes place with sodium iodide, there is a formation of iodoalkane in presence of acetone. This reaction is what? Frank-Stein reaction. Okay, next, now let's talk about the properties of these haloalkanes. So physical properties, when we talk about them, so lower alkyl halides are colorless with pleasant smell or pleasant oily liquid, except CH3F, CH3Cl, ethyl fluoride and ethyl chloride, which are gaseous in nature. So these are gaseous, other are colorless liquid, as well as they are what? They are having sweet smell. Certain are having sweet smell, certain are having pleasant oily liquids. Okay, pleasant smell hota hai, lekin they are what? Oily liquids. Alkyl halides have 18 carbon or more than it are solid in nature. So if there are any alkyl halides which are having more than 18 carbon atoms in their chain, or they are having 18 carbon in their chain, then they are solid in nature, right? This is the physical property we are talking about. Reactivity order for all these alkyl halides is what? Ri is more reactive than RBr, then RCl, then RF. Okay, why this is the case? Because the bond length between the carbon atom and the iodine, carbon atom and bromine, carbon atom and chlorine, carbon atom and fluorine, they are what? Go on decreases as we move from iodide to fluoride. So RF bond is very slow, very small, sorry, not slow. The bond is very small. So if I told you to break the bond, means a stick this small, and if I told you to break the stick this small, this much, if I told you to break the stick this much, if I told you to break this much, okay, which will be easy to break? So which is wider in shape, right? We can break it easily, but if it is very small stick, we cannot break it very easily. We need to break, we need more force to break it, right? So that is the criteria here. Again, the reactivity order of Ri, they can easily react because their bond is very large and less amount of energy is required to break it, and that's why the reactivity is high. Certain halide group reactivity order is tertiary halide, then secondary halide, then primary halide. So for same halide, if we talk about the order of reactivity, for suppose iodine is there, then the iodine present attached to the what? Tertiary will be more strong as compared to attached to the secondary, as compared to attached to the primary. Okay, यहाँ पे R group होगा, suppose कोई भी alkyl group होगा, होगा, ethyl होगा, कोई भी होगा. Okay, so this reactivity is like this way. Priority order when we talk about the, polarity order when we talk about these halides is that RF is more polar than RCl, then RBr, than Ri. You know Fazan's rule, right? Very good. So depending upon the size of this, the bond is what? Polar, as well as the electronegativity of fluorine is very, very high, and that's why the bond, the charge separation is high there, and that's why it is very, very polar bond. Very good. Now let's move on to the next. Melting and boiling points for the same alkyl group is in the order. So what is the order of the melting and boiling points? So Ri over RBi over RCl over RF. So this is a melting and boiling point for the same alkyl group. When present, iodide are showing highest melting and boiling. When you talk about fluorides and chlorides of the lighter, they are lighter than the water, whereas bromides and iodides are heavier than H2 due to higher density of bromine as well as oxygen. Right? Any doubt in this? You can ask the doubts. Yes. Okay, let's move on to the next topic, that is chemical properties of haloalkane. So how these haloalkane react with the other substances present. Okay, so if there is a alkyl halide, it reacts with the KOH to form alcohol. Okay, if alkyl halide reacts with water, it forms alcohol. If alkyl halide reacts with the sodium, what? This is what? NaOR. Okay, it forms what? ROR. What is ROR? It is what? Ether. Okay, ROR is what? Ether. There is a formation of ether, and this reaction we have seen in the preparation of ether also. Okay, no, ether is not happening, na? But you have seen this. Okay, next, alkyl halide reacts with sodium iodide, acetone, we get Ri. Right, ये reaction अभी हम लोगों ने देखा वो क्या था? Frankenstein reaction. When alkyl halide reacts with LiLH4, ना, this reaction is very very interesting reaction. There is a formation of hydrocarbon. ये reaction हम लोगों ने देखा है hydrocarbon के preparation में. There is a formation of hydrocarbon RH, LiX and AlCl3. So all the reactions are of which type? Nucleophilic substitution reaction. Okay, all the reactions are of nucleophilic substitution reaction. And we know that there are two types of nucleophilic substitution reaction. One is a SN1 reaction, and another one is what? SN2 reaction. Right? What is SN1 reaction? It is a unimolecular nucleophilic reaction which proceeds in two steps. Okay, it is what? Unimolecular. The molecules are what? One, nucleophilic substitution hai, but it takes place in two steps. First step is a slow step and second step is a fast step. In the first step, what happens is that there is a formation of carbocation takes place, and after that the carbocation get attacked by the incoming nucleophile. Okay, so here the rate of the reaction is what? It depends upon only the concentration of what? Our reactant molecule, and that's why this reaction is first order in nature. Reactivity order, when we talk about here, which reactant molecule will be more prone or very easily undergo into the nucleophilic substitution reaction. So it all depends upon the nature of carbocation going to form here. So that's why it follows the order of mechanism, that is tertiary or secondary or primary. So these will be more prone for the substitution reaction as compared to the primary one. Polar solvents, low concentration of nucleophiles and weak nucleophiles favor SN1 mechanism. So this is very, very important. We need polar solvent. We need low concentration of nucleophile. Even though concentration of nucleophile is low, the reaction is going to happen. Why? Because the rate only depends upon the first step, in which what is happening. Right? In SN1 reaction, partial racemization occurs due to possibility of frontal as well as backside attack of planar carbocation. So here both type of possibilities are there. The nucleophile can come from this side, from the frontal side, or nucleophile can come from the backside. So that's why partial racemization can take place. We can get the partial racemic mixture here. Okay, any doubt in this? Yeah, so let's move on to the next reaction, that is what? SN2 type. So in SN2 type, it is known as what? Bimolecular nucleophilic substitution reaction. These reactions are very, very, very important. SN1 and SN2. Okay? It is a second order reaction. Here, rate of the reaction depends upon both the reactant molecule as well as the incoming nucleophile. During SN2 reaction, what happens is inversion of configuration takes place. What is the meaning of inversion of configuration? So here, what happens is that when the reaction mechanism takes place, that is Rx, okay, it reacts with the incoming nucleophile OH minus. Then here what happens is that breaking of bond as well as making of bond takes place simultaneously. Okay, breaking of bond and making of bond takes place simultaneously. And what happens to this nucleophile is that here already the reactant molecule X, that is halogen, is present. That's why it avoids to enter from this side. So it comes from the back side. And that's why complete inversion of product we get. We get the complete inversion of product here. Okay, so inversion of product we get in SN2 reaction. Reactivity towards SN2 reaction is what? Primary is more reactive than secondary than tertiary here. C, it is reverse of SN1 reaction about the reactivity of halides. Rate of reaction in SN2 mechanism depends upon the strength of the attacking nucleophile. Here, nucleophile should be able to do this reaction. Okay, that's why the rate of the reaction depends upon mostly the strength of the nucleophile. Stronger the nucleophile, more easily the reaction is going to take place. Here, opposite of SN1, that is non-polar solvent favor, as well as strong concentration of nucleophile favor. Okay, strong nucleophiles as well as high concentration of nucleophile favor this given reaction, which is SN2 type of reaction. Right? Any doubt in this? So here there are several examples I have summarized here. So here ethyl bromide reacts with the given nucleophile. There is a formation of what? What has happened here? So there will be formation of CH2, CH2, Br. तो यहाँ पे क्या किया है? ये कार्बोकेटाइन फॉर्म किया है, ठीक है, H2O लिखा है और Br माइनस लिखा है. बाद में ये क्या होगा? Instead of this, I will just write CH3, CH2 and Br. Okay, CH3, CH2 and Br. So यहाँ पे ये product हम लोगों को मिलेगा. ठीक है. If suppose this molecule, which is what ethyl bromide, reacts with magnesium in presence of dry ether, what is going to form? So Grignard reagents are highly reactive and they react with any source of proton, H2 alkyl amines, to give hydrocarbon. So there will be production of what? Hydrocarbon, that is RR. Okay, there will be formation of what? Hydrocarbon, that is RR. So यहाँ पे क्या होगा? यहाँ पे form होगा हमारा CH3, CH3. तो यहाँ पे हमारा form होगा इथेन मोलिक्यूल. ठीक है, any doubt in this? So all is about haloalkane. Now let's start solving the previous year questions depending upon this given topic. So elimination reaction of 2-bromopentane to form pen-2-ene. Okay, what will be the answer here? Elimination takes place है, elimination हो रहा है, ठीक है. Elimination होते वक्त यहाँ पे हम लोगों को कौन सा product मिलेगा? Can you tell me the answer? Elimination reaction of 2-bromopentane to from pent-2-ene. Which type of reaction is it? Beta elimination reaction, follow Z-Zev rule, follow dehydrogenation reaction. It follow dehydrogenation reaction. Yeah, can you tell me the answer? A, B, C, D. Yeah, there are three type of mechanism taking place when there is a elimination taking place from 2-bromopentane. Yeah, can you tell me the answer? Yes. Okay. So now let's talk about the solution of this. Yeah, no one is answering. So I'm going to explain this. So here you can see the structure of 2-bromopentane. Okay, there is a what? 2-bromopentane. B answer. Okay. Let's discuss about this. Okay, Gauri Lakshmi? Yeah, good. So now see here what is happening is there is a 2-bromopentane I have shown here. You know now how to name the given organic compound also. Yesterday we have discussed about that. So here 1, 2, 3, 4, 5, 2-bromopentane elimination reaction is going to take place. During this elimination, what is going to happen? Minus HX is going to go. Okay. So यहाँ पे एक हाइड्रोजन है, ठीक है, यहाँ से एक हाइड्रोजन जाएगा और यहाँ पे भी एक पॉसिबिलिटी कि यहाँ से हाइड्रोजन जा सकता है, ठीक है. बट हियर पॉसिबिलिटी इज व्हाट? देयर विल बी एलिमिनेशन ऑफ दिस हाइड्रोजन एंड दिस ब्रोमीन एंड देयर विल बी फॉर्मेशन ऑफ दिस टाइप ऑफ अल्केन. व्हाई? बिकॉज हमको एक दिया था पेन-2-ene फॉर्म होने वाला है, ठीक है, इसलिए इसका नाम क्या हो गया? पेन-2-ene. Right? Any doubt in this? Okay. So how is the mechanism of this? So here what is happening? This is a alpha carbon atom and this is a beta carbon atom. So from beta carbon atom, what is happening? The hydrogen is going. Okay, hydrogen is going from beta carbon atom. That's why this is known as a beta elimination reaction, as beta hydrogen is abstracted and it results into the more substituted alkene. Okay, there is a formation of more substituted alkene. So more substituted alkene, when it forms, now it is known as a Z-Zev rule. When it is a low substituted alkene form, it is known as a Hoffman rule. So यहाँ पे कौन सा rule use हो रहा है? Z-Zev rule use हो रहा है, in which there is a beta elimination takes place, which is giving us the more substituted alkene. What is the more substituted alkene? See here, carbon-carbon double bond is substituted with this alkyl group, and hydrogen and hydrogen. If suppose this elimination has been take place, ठीक है, ये भी बीटा ही कार्बन है ना, ये बीटा है, ये भी बीटा है, ठीक है. अगर इधर से हमारा elimination होता, so what is going to form? Double bond. ये this is a carbon, this is the carbon, there is a R group here, and here only hydrogen and hydrogen, and here hydrogen. Okay, so this is less substituted benzene. So this will be what? Hoffman product. But right now we have got this product. So this is what? Z-Zev rule. Okay, so here H and Br are removed. It is what? Dehydrohalogenation. So that's why it is what? Which type of reaction? Very, very interesting problem actually. Okay, very good problem. So यहाँ पे beta elimination भी हो रहा है. It is following during that beta elimination Z-Zev rule, as well as there is what? Dehydrohalogenation is happening. That is means hydrogen as well as halogen is taking place. So that's why ABC is the answer. So which will be that option which contain ABC? So D is our correct answer, which contains ABC. Right? Do you understand this? Very, very good question actually. Yeah, Gauri Lakshmi, very good. So D will be the answer. Next, which of the following alkane cannot be made in good yield by Wurtz reaction? So do you remember what is a Wurtz reaction? Wurtz reaction is used to prepare which type of compounds? Yeah, from the options also you can tell me. Wurtz reaction is used for preparing which type of compounds? So it is used for preparing what? Alkanes, right? It is used for the preparing symmetrical alkanes. So see here, I have summarized the reaction. Wurtz reaction is used to prepare symmetrical alkenes like same. Okay, CH3, CH3, CH2, 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 CH3, like that way. So here what is happening? The given alkyl halide reacts with sodium and another molecule of alkyl halide in presence of dry ether to produce the symmetrical alkenes. So which of the following alkane cannot be made? So जो unsymmetrical होगा वो हम लोग बना नहीं सकेंगे, ठीक है. सो इफ R1 and R2 are different ना, then the mixture of alkane we obtain. For example, if R1X or R2X है, then we will get R1R1, R1R2 and R2R2. So this type of mixture we are going to get during the different R1 and R2 group present attached to a given halide. So here N-heptane cannot be made in good yield using Wurtz reaction since it is what? Unsymmetrical alkane. यहाँ पे आएगा अल्केन, ठीक है. तो यहाँ पे ब्यूटेन है मतलब 4 है, हेप्टेन है मतलब 6 है, ब्यूटेन है मतलब क्या है? 4 है, हेक्सेन है, ठीक है, हेक्सेन है. तो ये भी हम लोग प्रिपेयर नहीं कर सकते. सो वेयर इज हेप्टेन? बी, या हेप्टेन है, सॉरी 7 है यहाँ पे, हेक्सेन नहीं है. दिस इज हेप्टेन, सो दैट्स व्हाई वी कैन नॉट प्रिपेयर दिस. दिस इज व्हाट? अनसिमेट्रिकल. 7 नंबर है ना, अनसिमेट्रिकल ना, 7 नंबर. दैट्स व्हाई वी कैन नॉट प्रिपेयर एन हेप्टेन very accurately in a good yield by using Wurtz reaction. We can prepare it, but we cannot prepare it in a good yield, right? Very good. Next, in an SN1 reaction on chiral center, there is 100% racemization, inversion more than retention leading to partial racemization, 100% retention and 100% inversion. So tell me what is happen in SN1 reaction. SN1 reaction में क्या होता है? Inversion होता है, के retention होता है, के racemization होता है, क्या होता है? Yeah, can you tell me? Yes, कार्बोकटाइन फॉर्म होता है SN1 रिएक्शन में, राइट? In SN1 reaction there is a formation of carbocation and carbocation is planar in nature and that's why the intermediate form carbocation has possibility that the nucleophile can attack from below as well as above from the plane of a given molecule. Okay, from the plane of a given molecule R plus. Okay. Yeah, Lakshmi, there will be the B answer. Okay, so here what is happening? 50% chances of attacking from below as well as above the plane of the carbocation. So that's why here 100% racemization occurs, but it may not be highly probable. Okay, 100% racemization occur हो सकता है, लेकिन वो क्या है? It may not be highly probable. Why? Because if an inversion more than retention leading to partial racemization, there will be a partial racemization. 100% racemization नहीं हो सकता. इसीलिए हम लोगों का आंसर क्या हो जाएगा? बी, inversion more than the retention leading to the partial racemization. तो इसलिए हमारा क्या होगा? partial racemization यहाँ पे फॉर्म होने वाला है, 100% racemization नहीं फॉर्म होगा, right? Next reaction, two possible stereo structures of CH3, CHOH, COOH which are optically active are called. So if you talk about the structure of this given molecule, whether it is optically active, so the possible stereo structures of this will be diisomers of each other, isomers of each other, then enantiomers of each other and mesomers of each other. Okay, Gauri Lakshmi, see enantiomers. Yeah, let's see. Okay, so here for this given molecule, 4 different substituents are present. Like for a certain carbon atom, there is a hydrogen, there is CH3, CH, OH and COH. So 4 different substituents, only one chiral center is present. Okay, chiral center means what? A carbon atom to which 4 different groups are attached is known as a chiral center. So that's why this is a chiral molecule and that's why it can show the enantiomers. So Gauri Lakshmi, you are right. Here answer will be what? C. Very good. Next problem, which of the following compound will undergo racemization when solution of KOH hydrolyzes? Yeah. So which of the below compound will undergo racemization when KOH hydrolyzes with this? Yeah. Can you tell me the answer? 1, 2, 3, 4. Yes. Yeah, so I am going to explain you this. So in the first compound, second compound and third compound, you can see the chlorine atom is present at the what? We are talking about racemization. In SN2 reaction, what happens? For SN2, only inversion takes place. If we are talking about racemization, we must see about the reactant molecule, which consists of formation of carbocation, stable carbocation. Not only formation of carbocation, formation of stable carbocation. Then and then only the SN1 is going to favor them. So in all these reactant molecule, what do you think which is going to favor more about SN1 reaction? This is primary halide, this is primary halide, this is primary halide, but this is what? Secondary halide. So that's why this is going to undergo into SN1 reaction. And that's why option 4 will be whatever will undergo SN1 reaction with KOH solution. Hence, only this compound will undergo into partial racemization. Okay, compounds given in other options are not at all chiral. This is what? Chiral in nature. Okay, so that's why only option 4 will be the compound 4 will be undergoing into the racemization, right? Any doubts in this? Okay, next problem, which of the following acid does not exhibit optical isomers? So we need to find out here optical isomers. So what is the optical isomers? We have talked about that yesterday. Yeah, what is optical isomers? Which are having what? Yes, optical isomers कौन से होते हैं? Which of the following does not exhibit? Malic acid, alpha amino acid, lactic acid, and tartaric acid. Yes. Yeah, any answers? Okay, so see the structure of malic acid. You can see in malic acid, there is a double bond present. So we can arrange it in terms of Cs as well as trans. So it shows actually geometrical isomerism instead of what? Optical isomerism. Other acids, that is alpha amino acid, tartaric acid, and lactic acid, show optical isomerism. That is, they rotate the plane polarized light. Okay, D and L form is applicable for these three, but for malic acid, it is what? Actually geometrical isomer, but does not show any kind of optical isomerism. That's why our answer A will be the correct for this given molecule, for this given problem, right? Next problem, consider the reaction. You can see here reaction, two reactions are given. The mechanism of 1 and 2 are respectively. So we just need to find out what is the mechanism for the given reaction. First reaction is what? Which type? SN1 or SN2? Yes. How you are going to identify that? Identify the nucleophile nature, which is having strong nucleophile and which is having a weak nucleophile. See, in the first reaction, C2H5OH, and this is what? C2H5O minus, which is a strong nucleophile, guys. First one or second one? So this is what? Weak nucleophile. Okay, this is what? Strong nucleophile. Okay, whether we need strong nucleophile in SN1 or SN2, right? In SN2, we need strong nucleophile. In SN1, we need what? Weak nucleophile. Yeah. Yes, very good. Very good, Gauri Lakshmi. So in SN2, we need strong nucleophile. And that's why this will be what? SN2 reaction, and this will be what? SN1 reaction. Any doubts? There is only the difference is what? This. हमारा न्यूक्लियोफाइल में डिफरेंस था इस रिएक्शन में, इसलिए मैंने उस तरह से आप लोगों को एक्सप्लेन किया. स्ट्रॉन्ग न्यूक्लियोफाइल फेवर्स SN2 रिएक्शन and weak nucleophile favors SN1 reaction. Very, very important note, right? Okay, next question. Which of the following reaction is an example of nucleophilic substitution reaction? Yeah, RX, 2Na, RR. ये कौन सा रिएक्शन है हमारा? वर्ड्स रिएक्शन. दूसरा रिएक्शन देखो, यहाँ पे RH फॉर्म हो रहा है, यहाँ पे क्या हो रहा है? RXMG, RMGX फॉर्म हो रहा है, राइट? यहाँ पे क्या है? दिस इज व्हाट अवर सब्स्टिट्यूशन रिएक्शन, राइट? सो न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन हम लोग ये बोलेंगे क्योंकि यहाँ पे क्या हो रहा है? जो हमारा न्यूक्लियोफाइल है वो OH माइनस जो है वो ऐड हो रहा है. ठीक है, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन. न्यूक्लियोफाइल provides an electron pair to the substrate and leaving group departs with an electron pair. Leaving group departs with the electron pair. So this is what known as what? This is known as nucleophilic substitution reaction. Okay, any doubt in this? Yeah, hello, any doubt in this? So now let's move on to the next problem. Okay, so next problem देखो क्या है हमारा? How many stereoisomers does this molecule have? So we need to calculate how many stereoisomers are possible for this given halide. Yes, first of all, find out the what you are going to find out here, number of stereoisomers, how you are going to calculate some of the geometrical isomers. Okay, because यहाँ पे डबल बॉन्ड प्रेजेंट है तो वो भी हम लोगों को ऐड करने पड़ेंगे, एज वेल एज ऑप्टिकल आइसोमर्स इसके कितने पॉसिबल वो हम लोगों को फाइंड आउट करना पड़ेगा. सो सी हियर द नंबर ऑफ, दिस इज द स्ट्रक्चर ऑफ द मॉलिक्यूल CH3 CH डबल बॉन्ड CH CH2 CH CH3 Br. Okay, any doubt in this? No doubt, I have just written the structure of that. Okay, so number of geometrical isomers यहाँ पे कितने होंगे? डबल बॉन्ड होने के कारण एक सीज होगा और एक ट्रांस होगा. ठीक है, तो दो ज्योमेट्रिकल आइसोमर्स आ गया. और ऑप्टिकल आइसोमर्स यहाँ पे कितने पॉसिबल है हमारे लिए? कायरल कार्बन है ये, ठीक है, ये अलग ग्रुप है, ये अलग ग्रुप है, ये अलग ग्रुप है और हाइड्रोजन एक अटैच्ड है. सो दैट्स व्हाई कायरल कार्बन होने के कारण दो ऑप्टिकल आइसोमेरिज्म, यहाँ एक कायरल कार्बन होने के कारण दो ऑप्टिकल आइसोमर्स हमको मिलेंगे, एक D और L टाइप. So that's why 2 optical isomers are possible and 2 geometrical isomers are possible. So total stereoisomers possible are what? 4. Are you getting this? Any doubt? Yes? Okay, next. CH3CHCl, this is our molecule, has a chiral center. Which of the following represents the R configuration? So you know what is R face and what is S phase, S configuration and R configuration. So here what we need to do is draw the structure of this given molecule. Okay. After drawing this structure of the molecule, identify the chiral carbon atom. Okay. Identifying the chiral carbon atom, start giving the priorities to each group present attached to a given chiral carbon atom. So here I have done that. You can see here, this is a one carbon. ठीक है, ये carbon है वो, उसको क्या अटैच है, ये CH3 अटैच है, यहाँ पे मैंने लिख लिया CH3. ठीक है, उसको क्या अटैच है, Cl अटैच है, यहाँ पे लिख लिया Cl. उसको क्या अटैच है, ये CH2 CH3, that is what, C2H5, and it is attached to a hydrogen. So that's why this is our chiral carbon atom. Now start giving the priority order to all the substituents present at a chiral carbon atom. So here chlorine gets the first priority because being the more what we can say that its molecular weight is more, atomic weight is more as compared to the carbon. Next C2H5 will have more. Next CH3. Next what, hydrogen is the lowest in atomic weight, that's why it is the last priority group or substituent. So you can see the movement of this configuration is what, clockwise way, that's why this is what, R configuration. So which of the below is showing R configuration? So when we check that, na, B answer. Okay, B answer is what, our correct option. Okay, B option is what our correct answer. Next, this molecule you can see what is there, I minus Cl minus nucleophilicity would be. इसका ज्यादा increasing order होगा nucleophilicity के लिए. So nucleophilicity increases down the periodic table. So I minus will be more than Br minus, then Cl minus, than F minus. Right? Any doubt in this? Nucleophilicity governs the kinetics of a reaction, while basicity determines its thermodynamics. So if electronegativity decreases down the group, that is electropositivity increases, the nucleophilicity also increases down the group. But the order of the basicity will be like this. Basicity का order ये है, लेकिन nucleophilicity का order क्या है, ये है. समझ में आ रही है सब लोगों को बात? Very, very important point. Okay, this example is very important. So that's why option A is what, correct answer. Okay, any doubt in this? Next, reactivity order of halides for dehydrohalogenation. Yeah, this is very simple. What will be the order of halides for dehydrohalogenation? Yes, A, B, C, D, very simple. We have talked about this. Halides की क्या होगी हमारे order? Yes, A, B, C, D. Okay, so क्या होगी, the order of atomic size of halogen decreases in the order this way. Here the atomic size goes on decreases. So on moving down the group, atomic size what, increases. Right? Further the bond length decreases, and that's why it is in the order like this way. Hence the bond dissociation energy decreases in the order like this way, and that's why Ri being the weakest bond to break, and Ri will be most reactive. मैंने अभी आप लोगों को explain किया था कि बड़ी इतना अगर stick होगी, this much bigger is the stick, it is easy to break. Then is most reactive. Yes, nice. So now next problem, CH3, CH2, Cl, NaCN, NaH2. ये reaction हम लोगों को दिया है, X कौन सा होगा, Y कौन सा होगा, Z कौन सा होगा. We need to calculate. So Z is what we need to find out. So any answers? ओके सो यहाँ पे दिया हुआ है हम लोगों को हमारा इथिल हैलाइड, इसका रिएक्शन हो रहा है NaCN के साथ. सो व्हाट इज गोइंग टू फॉर्म हियर, देयर विल बी फॉर्मेशन ऑफ साइनाइड which undergoes into hydrogenation. Cyanide will get converted into respective amine which reacts with the acetic anhydride. Acetic anhydride हम लोगों को प्रॉब्लम में ही दिया हुआ है, which forms what, respective amide. So ये दो कार्बन थे, उसमें एक कार्बन ऐड हो गया क्योंकि साइनाइड आने के कारण, और ये साइनाइड के पास ये जो NH2 है उसने क्या किया, इस एसिटिक एनाइड्राइड के साथ रिएक्शन होने के कारण यहाँ पे एक्स्ट्रा COCH3 लगा. So 3 carbon NHCOCH3, which is the answer option A. Okay, which is the answer option A. Very good. Next problem, when this chloride is treated with NaNH2, which type of product is going to form? 1, 2, 3, 4. Yeah, can you tell me the answer here? So dichloro propane is going to treated with NaNH2. What is going to form? See here, this reaction we have already seen. Yeah, you can tell me the product. During hydrocarbon reaction, we have seen this reaction. Hydrocarbons का preparation के वक्त. Any answers? Okay, so here what is happening is when dihalide reacts with NaNH2 in terms of we give the heat, there is a removal of what? HCl. Okay, when H, here is H and here is Cl, they go and there is a formation of double bond here. That double bond again reacts with NaNH2 and there is a formation of final product, that is alkyne. So our B is our correct answer. Okay, we have seen this reaction, right? Okay, next reaction. Now let's talk about haloarenes. So what are haloarenes? How we can prepare them? Haloarenes are what consist of the benzene ring, to which when iron in presence of dark, the reaction takes place. There is a formation of such a type of chlorobenzene. Okay, we can prepare the different halides by forming the diazotization, by doing the diazotization reaction on given aniline molecule. So here there is a formation of this diazonium salt. Okay, this diazonium salt can easily undergo into reaction to form chlorides, bromides, iodide, and fluorides of a given benzene. So these are the 4 reactions which are very, very important to note. Okay, ये बहुत अच्छे और important reactions है. When it undergoes into reaction with Cu2Cl2, this reaction is known as Sand-Meyer's reaction. When it reacts with cuprous chloride, but in presence of HBr, there is a formation of Br. This is again a Sand-Meyer reaction. When it reacts with Ki, it is the what? Preparation of iodobenzene. And when it reacts with NaNO2 in presence of HBr, it is Bold-Sichmann reaction. There is formation of what? Fluoride. So यहाँ पे HF आएगा, not HBr. ठीक है, सो ये हो गए हमारे प्रिपरेशन के रिएक्शंस हमारे एलोअरेंस के लिए. व्हाट आर द फिजिकल प्रॉपर्टीज ऑफ दिस हेलोअरेंस? सो फिजिकल प्रॉपर्टीज, व्हेन वी टॉक अबाउट द फिजिकल प्रॉपर्टीज ऑफ दिस गिवन कंपाउंड्स, अरिल हैलाइड्स आर कलरलेस लिक्विड्स और दीज आर व्हाट? कलरलेस सॉलिड्स. Okay, they have very characteristic order, that's why they are known as, means they are aromatic compounds, they should have the aroma in them, and that's why they are having very characteristics order with them. Boiling point generally increases with increase in the size of the aryl group or halogen atom. Okay, so boiling point is in the order like this way. The melting point of para isomer is more than the ortho and meta isomer. This is because the symmetrical nature of para isomer. So you can see for para isomer, when we talk about the given chlorobenzene or any iodobenzene or any halide, so para is what? Symmetrical in nature, and that's why its melting point is more as compared to ortho, as compared to what? Para. This is ortho and this is what? Meta, sorry, not para, and meta. Okay, next, due to the resonance in chlorobenzene, CCl bond is shorter and hence its dipole moment is less than the cyclohexyl chloride. So this is again very, very good physical property. Next, what are the chemical properties? So these haloarenes undergoes into nucleophilic substitution reaction. So aryl halides are less reactive towards nucleophilic substitution reaction. Their low reactivity is due to the following reasons. So one is what? Due to resonance in C-X bond. There is a resonance present, partial double bond character is given to this bond, and that's why it is showing low reactivity towards the nucleophilic substitution reaction. Stabilization of molecule is happening due to the delocalization of electrons present in the given benzene ring. Okay, there is an instability of phenyl carbocation when it is formed during the reaction, and that's why they are what? Low, having low reactivity. However, aryl halides having electron withdrawing group. If the halides, suppose our molecule is consist of what? Electron withdrawing group with it, that is NO2 group. See here, NO2, NO2 or NO2. Okay, then the ortho and para position undergo into nucleophilic substitution reaction easily. NO2 हो, SO3H हो, ठीक है. ये क्या है? हमारे इलेक्ट्रॉन विड्रॉइंग ग्रुप से स्ट्रॉन्ग इलेक्ट्रॉन विड्रॉइंग ग्रुप, ये अगर प्रेजेंट होंगे तो हमारी रिएक्शन बहुत इजीली फेवर हो जाती है. और यहाँ पे आप देख सकते हो रिएक्शन हो रहा है और फॉर्मेशन भी हो रहा है प्रोडक्ट. या एनी डाउट इन दिस? यस. Next, electrophilic substitution reaction takes place in this given haloarenes, and how that takes place? So haloarenes are what? Orthopara-directing due to the plus I effect of this chlorine or halides. Okay, halides show orthopara direction. So means incoming nucleophile on benzene ring. If suppose this is our halobenzene, okay, or haloarenes is there, they are ortho and para-directing. So the incoming nucleophile come the incoming electrophile, sorry, not nucleophile, is going to come at ortho or para position. ठीक है, एनी डाउट? प्लस इफेक्ट होता है उनका, प्लस आई इफेक्ट. ठीक है, हेलोजिनेशन होता है, नाइट्रेशन होता है, सल्फोनेशन होता है, फिल्टर रिएक्शन जैसे होते हैं हमारे बेंजीन पे, उसी तरह से ये सारे रिएक्शन हो सकते हैं. ठीक है. Another reaction is Wurtz-Fittig reaction in which halide, benzyl halide reacts with the alkyl halide to form the bigger molecule of hydrocarbon. ठीक है. Fittig reaction. Here two molecules, if we take about the haloarenes, there will be formation of what? This type of compound. Right? These are the chemical properties. Now let's talk about the previous year questions of this given topic. The hydrolysis reaction that takes place at the slowest rate among the following is. So which reaction is going to take place at a slow rate? Just now we have talked. Yeah, what will be the answer? कैसे होंगे जिसमें रिएक्शन स्लो होगा वो कौन होंगे? स्लो कौन होगा? यस, यहाँ पे देखिए मैंने आप लोगों को अभी कहा जो हमारे aryl halides होते हैं, they are slow because there is a partial double bond character present here. Okay, if there are any electron withdrawing group present, then only the reaction is going to take place. So that's why this is what slowest. Okay, तो यहाँ पे अगर कोई इलेक्ट्रॉन विड्रॉइंग ग्रुप होता तो ये रिएक्शन हो सकती थी. अगर यहाँ पे इलेक्ट्रॉन विड्रॉइंग ग्रुप नहीं है तो ये रिएक्शन नहीं हो सकती. तो यहाँ पे क्या हो जाएगा? aryl halides do not give substitution reaction. ओके, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन के लिए वो स्लो हो जाते हैं. इलेक्ट्रोफिलिक सब्स्टिट्यूशन वो देंगे लेकिन न्यूक्लियोफिलिक सब्स्टिट्यूशन वो नहीं देंगे. Next, the compound undergoes in the following reaction. The product C is, okay, there are A, B, C. First reaction is C7H8 reacts with chlorine, then Br2, then zinc. So see here, C7H8 means what? Our toluene molecule. When it reacts with chlorine, it forms CCl3. This molecule. When it reacts with Br2, now what happens is that there is a electrophilic substitution reaction takes place. So there is what? Formation of meta product. When this product reacts with zinc, when this reaction takes place, yeah, when this reaction takes place, there is a formation of bromotoluene. Okay, ये CCl3 का conversion हो रहा है. यहाँ पे क्या हो रहा है? Reduction हो रहा है and there is a formation of M-bromotoluene. So meta-bromotoluene यहाँ पे form होता है. ठीक है, CH3 get converted into CCl3. ठीक है, heat दिया Cl2 के साथ हमारा मीथेन रिएक्ट होता है. मैंने जैसे आप लोगों को बताया था थोड़ी देर पहले रिएक्शन में, तो वहां पे क्या फॉर्म होता है? CCl3. Br2 का रिएक्शन होने के कारण यहाँ पे मेटा सब्स्टिट्यूशन हो रहा है. ठीक है, इन डाउट्स? नेक्स्ट रिएक्शन, नेक्स्ट प्रॉब्लम. विच ऑफ द फॉलोइंग रिएक्शंस, ठीक है, 1 2 3 फॉलो द फॉलोइंग रिएक्शन. विच ऑफ द फॉलोइंग स्टेटमेंट इज करेक्ट? ठीक है, 3 स्टेटमेंट हम लोगों को, 3 रिएक्शन दिए हुए और हम लोगों को कुछ स्टेटमेंट दिए हुए. 1, 2 are elimination reaction and third is addition reaction. First is elimination, second is substitution, and third one is addition reaction. First one is elimination, second and third are substitution reaction. First one is substitution, second and third are addition reaction. So observe all the 3 reactions. You can see all the 3 reaction. In all these 3 reaction, which is what? Addition, elimination, or substitution. So see here one by one. First reaction, when we talk about it, CH3 CH2 Br reacts with KOH to form alkene. So this is which type of reaction? Dehydrohalogenation reaction. So यहाँ से कुछ तो भी मटेरियल बाहर निकल रहा है, इलिमिनेट हो रहा है. ठीक है, सो ये किस प्रकार के रिएक्शन है? ये इलिमिनेशन टाइप के रिएक्शन है. ठीक है, सो सेकंड रिएक्शन इज इलिमिनेशन रिएक्शन. कहीं पे दिखा है क्या सेकंड रिएक्शन इज इलिमिनेशन रिएक्शन? ओके, फर्स्ट ऑप्शन में ही दिखाया है कि सेकंड रिएक्शन इज व्हाट? इलिमिनेशन रिएक्शन. फर्स्ट इज इलिमिनेशन, सेकंड इज सब्स्टिट्यूएंट. हमारा जो फर्स्ट रिएक्शन है, सॉरी नॉट सेकंड, फर्स्ट रिएक्शन इज एलिमिनेशन. तो यहाँ पे भी दिया हुआ है, यहाँ पे भी दिया हुआ है, यहाँ पे भी दिया हुआ है. तो ABC. ओके, सेकंड रिएक्शन देखिए क्या हो रहा है. यहाँ पे ये जो हमारा मॉलिक्यूल है उसकी रिएक्शन हो रही है हमारे KOH के साथ. राइट, इट इज रिएक्टिंग विद KOH. ओके, देयर इज अ फॉर्मेशन ऑफ this alcohol. So this is which type of reaction? I think this is what? Substitution type of reaction, right? It is what? Nucleophilic substitution type of reaction which we have seen here. Okay, so replacement of Br minus by OH minus, that is what? This is a substitution type of reaction. So second substitution hai, first one very good. Next reaction, that is third reaction. You can see above reaction involves what? Addition of Br2 molecule. Across this double bond there is the addition of 2 bromine atoms. ठीक है, यहाँ पे क्या हो रहा है? एडिशन हो रही है 2 ब्रोमीन एटम्स की, एंड दैट्स व्हाई दिस इज व्हाट? एडिशन रिएक्शन. तो पहली क्या है? इलिमिनेशन, दूसरी क्या है? सब्स्टिट्यूशन, और तीसरी क्या है? एडिशन. तो ये सारा ऑप्शन किस में है? इलिमिनेशन, सब्स्टिट्यूशन एंड एडिशन, ऑप्शन बी. तो आंसर विल बी व्हाट? ऑप्शन बी. इन डाउट्स? we just needed to observe the reactions and we just find out which type of reaction it is. Okay, so which of the following biphenyl is optically active? So all are biphenyl compounds, and which is optically active, that we need to find out. So first two, 1, 2, 3, 4, there are 4 options given. So what is the criteria? In option A, you can B option. Okay, very good, Gauri. Gauri Lakshmi, your answer is correct. Option B is correct answer. Why is it that? So see the answers. In option A, there is no chiral carbon. ओके ऑप्शन ए में कायरल कार्बन ही प्रेजेंट नहीं है. हमको कायरल कार्बन चाहिए, मतलब क्या चाहिए? टू अ गिवन कार्बन 4 डिफरेंट सब्स्टिट्यूएंट शुड बी अटैच्ड. ओके, इन ऑप्शन सी देयर एग्जिस्ट सेंटर ऑफ सिमेट्री. यहाँ पे क्या प्रेजेंट है? सेंटर ऑफ सिमेट्री प्रेजेंट है. ठीक है, अगर हम प्लेन पास करें तो यहाँ पे क्या है? इस सेंटर से यहाँ पे और इधर 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 किधर भी जाओ, स्ट्रक्चर क्या है? सेम ही. ऑप्शन डी, देयर इज एग्जिस्ट ऑफ प्लेन ऑफ सिमेट्री. ओके, ऑप्शन डी में क्या है? अगर हम I pass a plane along this ना molecule. So इस साइड में और इस साइड में, दोनों साइड में मॉलिक्यूल क्या दिख रहा है? सेम दिख रहा है. So it having plane of symmetry, this is having center of symmetry. There is no chiral carbon present. Okay, and that's why option B. Okay, option B में क्या हो रहा है? There is a restricted motion as well as the carbon atoms are having different substituents. Okay, and that's why this is optically active. Okay, right? Next, in which of the following compounds CCl bond ionization shall give most stable carbocation? तो यहाँ पे किसके लिए हम लोगों को अच्छा कार्बोकेटाइन मिलने वाला है? Any answers? Yes. ऑप्शन ए बी सी डी. यहाँ पे हमारा आंसर क्या आएगा? ऑप्शन बी. यहाँ पे जो हमारा कार्बोकेटाइन फॉर्म होगा वो क्या कर सकते हैं? हम डिलोकोलाइज कर सकते हैं. ठीक है, दिस इज द बेंजिल कार्बोकेटाइन एंड दैट्स व्हाई इट विल बी मोर स्टेबल. ओके, नेक्स्ट, which product, what product are formed when the following compounds is treated with Br2 in presence of FeBr3? तो ये जो हमारा कंपाउंड है, इसकी रिएक्शन अगर मैं Br2 के साथ करती हूँ तो मुझे किस टाइप का प्रोडक्ट मिलेगा? ठीक है, यहाँ पे है ऑर्थो, यहाँ पे है पैरा, यहाँ पे है ऑर्थो, यहाँ पे है ऑर्थो. ठीक है, यहाँ पे है ऑर्थो, यहाँ पे है पैरा, यहाँ पे है पैरा एंड यहाँ पे है मेटा. तो कौन से प्रकार के प्रोडक्ट हम लोगों को मिलेंगे अगर 2 मिथिल ग्रुप वहां पे प्रेजेंट है? तो सी रिएक्शन मिथिल ग्रुप आर व्हाट? ऑर्थो पैरा डायरेक्टिव. But due to here steric hindrance, what happens is that there is a generation of 2 CH3 group substitution will not takes place on position 1. Okay, ये position 1 है, ये position 2 है, ये position 3 है, मैंने दिखा हुआ है. Hence only 2 products are possible. So which 2 products are possible? So this product, that is product C, is possible. First of all, Br2 FeBr3 क्या करेगा? पैरा पे अटैक कर लेगा और पैरा प्रोडक्ट फॉर्म करेगा. पैरा प्रोडक्ट फॉर्म होने के बाद यहाँ पे कौन सा प्रोडक्ट फॉर्म होने की ज्यादा पॉसिबिलिटीज है? फर्स्ट पोजीशन पे तो आएगा ही नहीं कोई भी न्यूक्लियो कोई भी इलेक्ट्रोफाइल, क्योंकि यहाँ पे क्या है? बहुत ज्यादा स्टेरिक हिंड्रेंस हो जाएगा. एक साथ 3 ग्रुप एक बहुत पास पास में आ जाएंगे. दैट्स व्हाई देयर विल बी द स्टेरिक हिंड्रेंस ऑब्जर्व एंड दैट्स व्हाई फर्स्ट पोजीशन विल बी नॉट फेवर्ड. सो सेकंड और थर्ड में होगा. तो यहाँ पे अगर आया तो ऑर्थो मिलेगा, यहाँ पे अगर आया तो पैरा मिलेगा. सो व्हाट इज दैट? दोस 2 स्ट्रक्चर्स. सो ऑप्शन सी में आप देख सकते हो, यू कैन सी इन ऑप्शन सी दैट these 2 आर पॉसिबल, आर ऑब्जर्व. ओके, नेक्स्ट, yeah, the replacement of chlorine of chlorobenzene to give phenol requires drastic conditions, but the chlorine 2,4-dinitrochlorobenzene readily replaced since. So why the replacement of chlorobenzene in chlorine we get phenol? Okay, but during this reaction we need a drastic conditions, but chlorine of 2,4-dinitrochlorobenzene readily replaced. क्लोरोबेंजीन में अगर मैंने क्लोरीन निकालना चाहा रिएक्शन करते वक्त, so removing this is very drastic. Okay, but removing the chlorine from this molecule is easy. Why? Because NO2, what it does, it deactivates the ring. Okay, it is an electron withdrawing group, it deactivates the ring and hence withdrawal of electron from ortho and para position is, यहाँ पे ये बेंजीन रिंग पे इलेक्ट्रॉन इसलिए क्लोरीन प्रेजेंट. ठीक है, क्लोरीन इलेक्ट्रोनेगेटिव एलिमेंट, वो क्या करेगा? पुल करेगा खुद के तरफ इलेक्ट्रॉन्स. लेकिन यहाँ पे ऑलरेडी मोर स्ट्रॉन्ग इलेक्ट्रॉन विड्रॉइंग ग्रुप प्रेजेंट है, वो ऑलरेडी पुल कर रहे हैं इलेक्ट्रॉन्स टुवर्ड्स इटसेल्फ. दैट्स व्हाई दिस बॉन्ड बिकम्स वीक एंड रिमूवल ऑफ दिस मॉलिक्यूल इज इजी. ठीक है, ये मॉलिक्यूल में से हम लोग जब क्लोरीन निकाल रहेंगे, दैट मोशन विल बी इजी, दैट प्रोसीजर विल बी इजी एज कंपेयर टू दिस, बिकॉज हियर only chlorine atom is there to share all the electrons present on the benzene ring. Right? So here what is the answer? D, nitro group withdraws electron from the ortho and para position, and that's why it is easy for the chlorine present on the benzene to undergo into substitution or replacement. Next, benzene reacts with N-propyl chloride in the presence of anhydrous LCl3 to give. So ये reaction बहुत easy है, हम लोगों ने देखी है ये reaction कौन सी reaction है? This is what Friedel-Crafts alkylation reaction, right? So यहाँ पे anhydrous LCl3 की reaction हो रही है, benzene है, alkyl halide है, यहाँ पे क्या form होगा? इस प्रकार का isopropyl benzene form होगा. That is what our option is D. Next, chlorobenzene reacts with magnesium in dry ether to give a compound A which further reacts with ethanol to it. So this reaction is very easy again. Chlorobenzene की reaction करो magnesium और dry ether के साथ, आपको मिलेगा हमारा what? Grignard reagent. Grignard reagent की reaction अगर आप अल्कोहल से कीजिएगा तो आपको क्या मिलेगा? बेंजीन फ्री मिलेगा, और ये हमारा जो Grignard reagent है वो इसके साथ कॉम्प्लेक्स फॉर्म करेगा. This is what our benzene molecule. So answer is what? B. Very simple and important reaction. ठीक है, इसे इस प्रकार की reaction भी आ सकती है एग्जाम में. Next, let's talk about the very short topic present in this chapter, that is polyhalogen compounds. So there are certain compounds which are polyhalogen, and which are those dichloromethane and tetrachloromethane, then freon, okay, and DDT. So these are the four compounds which are polyhalogen compounds. So what is dichloromethane? It is useful as solvent in industry. Mostly it is used as a solvent in production of chemicals, used in removal of color. Okay, it is harmful to a nervous system, and that's why it gives red rashes and everything. But this is very important solvent. Tetrachloromethane is again a very good substance which is used in the manufacture of refrigerant and propellants of aerosol cans. It is used as a cleaning agent. It is used in a fire extinguisher. Okay, so there are several uses of tetrachloromethane. Next, freons. You know freons, right? Freons means what? Chlorofluorocarbon. They are collectively compounds of methane and ethane, and freons are manufactured by using Schwarz reaction. ठीक है, फ्रेयन 12 आपको पता है वो कहाँ पे प्रेजेंट है? इंडस्ट्रियल यूज में वो फ्रेयन मोस्ट कॉमनली निकलता है, और फ्रेयन इज रिस्पॉन्सिबल फॉर डिस्टर्बेंस ऑफ ओजोन बैलेंस प्रेजेंट इन अवर एटमॉस्फेयर. ठीक है, एटमॉस्फेयर मतलब ओजोन के डिप्लीशन के लिए कौन सा रिस्पॉन्सिबल है केमिकल? सो दैट इज फ्रेयन. DDT is what? Very good insecticide. Okay, it is used into the it is used as an organic pollutant. Okay, which can act as a both sink as well as long-term source of exposure for organic affecting organisms. It is not metabolized very rapidly by animals. वो अच्छे से मतलब इतने easily नहीं होता है, और ये इसीलिए अच्छा इतने easily वो metabolize नहीं हो जाता है animals के पास से, इसीलिए that is very good pollutant. Okay. Very good. Now there are several problems, 2 to 4 problems depending upon these polyhalogen compounds. So tell me the answer. Let's solve this. Trichloroacetaldehyde reacts with this molecule, okay, chlorobenzene, in presence of sulfuric acid. Which product you are going to get? So see the reaction here. I'm going to show you the reaction. So this is what our trichloroacetaldehyde. Okay, this is our trichloroacetaldehyde. When it reacts with chlorobenzene molecule in presence of concentrated H2SO4, we get DDT. So this is the preparation of DDT reaction. ठीक है, तो ये प्रॉब्लम बहुत इंपॉर्टेंट है. जब क्लोरोबेंजीन रिएक्ट होता है हमारे trichloroacetaldehyde के साथ in presence of acid, there is a formation of DDT. And what is the structure of DDT? Structure of DDT is this one. ठीक है, ऑप्शन सी. क्लोरोबेंजीन ये CH है और उसको CCl3. ठीक है. Next problem. Which of the following is responsible for depletion of ozone layer in the upper strata at atmosphere? Yeah, tell me. Polyhalogen, ferrocene, fluorines, freons. कौन है responsible ओजोन लेयर के डिप्लीशन के लिए? अभी मैंने आप लोगों को बताया freons are the compounds. Yes, very good, Sushant. So freons are the compounds which are responsible for depletion of ozone layer in the atmosphere. Yeah. See, chlorofluorocarbons. What is the structure of freons? CF2Cl2, CHF2Cl2, HF2CHCl2. These are non-inflammable, colorless, and stable up to 550 degrees Celsius. These are emitted as a propellants in aerosol spray, refrigerators, firefighting reagents, etc. And they absorb UV rays in the atmosphere. Okay. So these are what? Chlorofluorocarbons. That is what? Freons, which are responsible. Okay. They absorb UV rays in the stratosphere and produce few free atomic chlorine, which results into the डिकम्पोजिशन ऑफ ओजोन। वो क्या करते हैं, यूवी रेज एब्जॉर्ब कर देते हैं और उसके वजह से देयर इज अ प्रोडक्शन ऑफ एटॉमिक क्लोरीन, एंड व्हेन एटॉमिक क्लोरीन इज प्रेजेंट देयर इज अ डिप्लीशन ऑफ ओजोन लेयर हैपनिंग। Okay, chlorofluorocarbons are chemically inert and hence do not react with any substances with which they come in contact, and therefore they float through the atmosphere, and as a result of it, they enter into stratosphere directly, and when they enter into stratosphere they absorb the UV rays, and due to the absorption there is a removal of chlorine from them, and this chlorine affects the ozone layer, right? Next, chloropicrine is obtained by the reaction of, so chloropicrine is one molecule, okay, which is the polyhalogen compound, is obtained by reaction of, so which with the help of which reaction we are going to get the chloropicrine. So see here I have summarized the reaction. So chloropicrine is a nitrochloroform. What is the structure of this? Nitro compound hoga or CCl3 hoga. It is obtained by nitration of chloroform. So chloroform ka nitration when we takes place now, there will be formation of chloropicrine. So it is a poisonous and it is used as an insecticide and a war gas. Okay, so very, very poisonous gas. So that is what our chloropicrine, right? Yeah. Next, phosgene is a common name for, yeah, this is very simple. Can you tell me the answer of this? Phosgene? Yes, phosgene is a common name for phosphyl chloride, thionyl chloride, carbon dioxide and phosphine, and carbonyl chloride. So phosgene, what is this? Thionyl chloride, you know, SOCl2, right? Carbon dioxide, you know, as well as phosphine, you know. Yes. अभी ये दो तो मैंने बता दिए, right? Phosphine means what? Phosphine का पता है स्ट्रक्चर आप लोगों को? हेलो, यस, बताइए. phosphine, yeah, what will be the structure? phosgene कौन सा होगा हमारा? Which will be the phosgene here? Carbonyl chloride, phosphoryl chloride, thionyl chloride. Phosphine is what? PH3 is what? Phosphine, right? तो ये भी नहीं है, ये भी नहीं है. कार्बोनिल क्लोराइड कौन सा होता है? यस, और फॉस्फोरिल क्लोराइड. फॉस्फोरिल क्लोराइड phosgene नहीं होता है, और कार्बोनिल क्लोराइड क्या होता है हमारा? COCl2, and which is known as what? Phosgene. Are you getting it? Are you getting it? Yes, any doubt? Yeah. Hello. Yes, any doubts in this? What is phosphoryl chloride again? P double bond O. ठीक है, और यहाँ पे होता है Cl, यहाँ पे होता है Cl, और यहाँ पे होता है हमारा Cl. So this is our phosphoryl chloride, this is our thionyl chloride, and this is our CO2 and phosphine, right? And this is our carbonyl chloride, which is known as a phosgene. ठीक है, phosgene मतलब phosphorus नहीं होता है उसमें. ठीक है, ये बात ध्यान में रखना है. So that's it for today's lecture. Okay, anyone have any doubts? Yes. If you have any doubts, you can talk to me right now. Thank you so much for joining in. Yeah, thank you, Gauri Lakshmi, for joining in. Tomorrow we are going to meet again for the next topic, that is alcohol, phenol, and ether, right? Tomorrow again we are going to follow the same. We'll discuss the important topics, and later on we are going to solve the problems. If you have any doubts, you can talk to me. Okay.